Hello friends, today we are discussing the subject microprocessor. In this lecture series, today we are discussing the serial communications protocols. Serial communication protocols, a serial peripheral communications interconnection, that is the SPI. See, that is another way we can say a serial communication protocols. The another kind of the serial protocol is in an embedded system. This is an SPI, which is another kind of the serial protocols in a embedded system. The four wire protocols: S clock, serial clock, MOSI, SIMO, master output, and slave input. Master input and slave output, MISO and SOIMI. That is a master input, MISO, and a slave output as a SOMI. SS is the slave select. Okay, a single master device with a one or more slave devices. It can support for a single device which acts as a master and with a multiple device which acts as a slave. This can provide a master slave communication. So a single device can be acts as a master. So generally the master may be the microcontroller, microprocessor, or the processors which can able to handle the number of queries at a time. The higher throughput than I2C and do not can do the stream transfers. So SPI provides the higher throughput than the I2C and can do the stream transfer. Higher throughput than I2C and can do the stream transfer. No arbitration is required. So here the higher throughput, the serial peripheral interconnection, that is then SPI provide the higher throughput than the I2C and can do the stream transfer. No arbitration is required, but required the more pins as compared to the I2C. There are only two wires are there. It requires the more pins. Has no hardware flow control. Here the flow control is there. There is no hardware in a flow control. That means a flow control, we know that a sender transmits a data, receiver receives a data. If a sender able to transmit a data at a higher rate, that means we can say 100 packets per second, and a receiver unable to receive a data at that rate, that means there may be a certain loss of the data. So to avoid that, a flow control should be there, but here no hardware for the flow control is there. No slave acknowledgement that a master could be talk thin air and do not even know it. So here there is no, again there is no acknowledgement is there. So that means a master transmits a data, and transmits a data. He doesn't know whether a data is received successfully at the another end. So it is, that's why it is says as a master can talk a thin air, talking to the thin air and do not even know it. So this is an phrase just here, you explain here just to come to know that the master is doesn't know whether a data is received at the another end successfully or not. So he is just transmitting a data repetitively or continuously, not a repetitively. Repetitively means if there is an acknowledgement policy, acknowledgement is received. If an acknowledgement is not received, a master has to send a data again. In that case, we can say that is a repetitive. But here, the no acknowledgement policy is there. That means a master who is transmitting a data and who continuously transmit a data, ignoring that whether a receiver receives a data or not. A serial bus protocols, what is the SPI? Serial peripheral interconnection. That is it consists of the serial bus protocol, which is easy, fast, and simple. Everyone supports it. As we discuss it, everyone supports means it can use only the from one point to point devices. That's why it is supported by everyone. It is a easy, it is a fast, and it is a simple. So it is fast, that means it is a point to point communication is there. That's why it is a fast, it is a simple. So because as a bit by bit a serial bit transmission is there, that's when bit by bit data is transmitted, that's why it is a simple one. Okay, so everyone supports it. That means whenever we go for the communication from a monitor to the CPU or CPU to the monitor, a cable which is connected, which is serial pair, serial bus pin. Okay, so that's why the such connections are a point to point connection, a communication is done there. And there it is easy, fast, easy to use, simple and fast. SPI basics. The basics communication, a communication protocol using the four wires. It is known as the four wire bus. As compared to the I square C uses only the two wires for the communication. The SPI uses a four wires for the communications. It uses to communicate across the small distances. It used to communicate across the small distances. SPI basic communication doesn't support for the larger distances as it is a serial communication, so it doesn't support for the larger distances. A pair master slave or a single master is there. It a multiple slave and but a single master. We can't say it is a master slave configuration. Okay, here the single master is there and number of slaves are there. Master who becomes a master, a device, generally microprocessor, microcontroller, or a processor who transmits a data becomes a master, and a device which receives a data becomes a slave. In the case of the SPI, a number of slaves may be the more, but a master may be single one. So here we can't say it is a master slave configuration, but in the master slave configuration, this is the thing that a master, a, a machine or a device who has a data transmit a data at that time, that becomes a master. But in case and receiving that device becomes a slave in that case. But when a receiving device having certain data, in case of a master slave configuration, a receiving device becomes a master, and a sender device becomes a slave at that time. That's why here we can't say this is a master slave configuration, but it is a master. It supports for a single master and a multiple slave. A synchronization is there between a sender and a receiver. For that, a clock signal is there. A clock signal synchronization is there. That's why a data is transmitted within the clock signal that is synchronized clock signals. That is the, we can say, a synchronization is there. The capabilities for the serial parallel communication are interfacing. Always full duplex is there. It is a full duplex. As we know that a full duplex, that means a master can transmit and a receiver can transmit. That means if a master having a data, it can able to transmit to the slaves, or if a slave having certain data, it can transmit a data. That means a transmission and a receiving can be done, transmission and a receiving can be done at the same time. That is the full duplex. A communication in two direction at the same time. That means a transmitter and a receiver can transmit and receive the data at the same time. A transmission need not to be meaningful. That is known as the full duplex. Whereas a half duplex means, in case of the half duplex, only the sender can transmit a data and receiver can receive a data. Whereas in case of the full duplex, a sender transmit a data for a receiver, and if the receiver having certain data, it can again transmit the data at the same time. That is a full duplex communication. Multiple megabits transmission speed is there. SPI can able to communicate with the multiple megabits transmission speed. It can transfer a data into 4 to 16 bit characters. It can multiple slaves, a decisioning possibility. It has a multiple slave. It can provide some multiple for that multiple slave and a single master. It can support for the decisioning system. That means a device having a data can able to transmit to the master, and a master having a data for a device can able to the transfer a data to that particular, that in the decisioning policy a device is selected repetitively. SPI protocol, as we see in a figure, SPI master is there and SPI slaves are connected with a S clock, MOSI, IOSI, SS1, SS2, and SS3 signals are there. That is the master out, slave in, MOSI, master in, slave out, that is a MIOSO, and a system clock, SLK, and a select one, that is a SS1. So master slave select low, a master generates the clock and shift register shift in and out data. SPI wires in details. The MOSI, that is carries data out of the master to the slave. This wire MOSI carries a data out of the master to the slave. MISO carries a data from slave to the master. Both signal happen for every transmission. SS bar, unique line to select the slave. S clock, master produced clock to synchronize a data transfer. Master produce a data. Master produce a clock to synchronize a data transfer. As shown in the figure, SPI uses a shift registers model of the communication. It uses the shift register model for the communication. A master and a slave is there. A 0 bit is transferred to the MISO or MOSI. So the 7 bit goes to the first bit. This is a master shift out data to the slave and shifts in a data from the slave. Means a shift register communication is done. That is a data transmission is done in a shifting formats, bit by bit from the master to the slave and from the slave to the master. How the communication in a SPI serial parallel interfacing is done. A master slave communication is there, S clock signal is there, master out slave in is there, master in slave out is there, and SS signals are there. These are respectively connected with the S clock. If the clock signal is high, at that time the bits data is transmitted. When clock signal is low, data is not exchange or a change in the data is there. So here a communication is takes place as shown in the master out, slave in, and a master in, slave out. Master to slave communication, the clock signals are here. When the 0 is there or when at the rising edge, the signals are sent as a so, and at the rising edge, the signals are sent from the master to the slave. SBI clocking, there is no standard way. The four clocking modes are there, two phases, two polarities. Masters and selected slave must be in the same mode. During the transfer with the slave A and the B, master must configure clock to the slave A clock mode. Select a slave A, it will do the transfer. Deselect the slave A, configure clock to the slave B's clock mode. Select the slave B, it will do the transfer. The deselect the slave B, master reconfiguration is done. SPI timing diagram as shown in a figure. The timing diagram as shown in a figure showing the clock priorities, polarities, and clock phases as shown in a figure. Thank you friends for watching the video.